flask is charged with 0.100 moles of A and allowed to react to form B. And you are given the moles of A remaining versus time. A, calculate the number of moles of B at each time in the table. Okay. Calculate moles of B at each time. So the reaction is A becomes B. Okay, so the amount of A consumed is equal to the amount of B formed. Amount of A consumed equals amount of B formed. So that there is our analysis. So therefore, amount of B is equal to initial amount of A minus final amount of A. So that would be the initial amount of A is 0.100 moles, so it's 0.100 minus final amount of A. Okay, so now let's tabulate our values. So we have a column for time, a row for time. We have a row for moles of A. And we have a row for moles of B. At time 0, you have 0.100 moles of A, and you have 0 moles of B. You haven't consumed any A, therefore you haven't formed any B. Next, at time 40 seconds, the moles of A is given as 0.067. And it follows that the moles of B is the initial amount of A, 0.100, minus the final amount of A, which is 0.067. 0.067, that gives you 0.033 moles of B. At time equals 80 seconds, the moles of A is 0.045. So therefore the moles of B is 0.100, the initial amount of A minus the final amount of A, 0.045. That should be 0.055 moles. Next, at time 120 seconds, the moles of A is 0.030, and the moles of B is 0.100, initial amount of A minus the final amount of A, 0.030, 0.070. And finally, at T equals 160 seconds, the moles of A is 0.020, and the moles of B then would be 0.100 minus 0.020, 0.080. This is moles, and this is moles.